Excellent. So let's go ahead and get started. So first things first, we're going to take these two pictures here. Try my best to keep them in the camera. Remember that this is our source. This is the drawing, okay? To start off everything, before I even begin putting on the box and the halves, quarters, and thirds, let me just reiterate what is our master rule. What's the one thing we never do? We never take a measurement and steal it and try to bring it to the other side. Because if we do that, the moment that we try to do that, it is automatically going to be wrong because we are dealing with two completely different sizes. Let it focus. A little bit brighter. There we go. Okay, so first things first, we need a box. We know we can always put our subjects in a box. I've provided one box here for you, so we just need to go take care of the other box. So we need to find out where the farthest extremes of our left, right, top, and bottom, which will be very simple because we're dealing with an actual piece of paper here. Now I'm going to show you a little trick. Now you may have found when you go to do this side where you only have the two small boxes, it's kind of a little hard to figure out how to keep everything straight, right? Like what if it's angled a little bit wrong? You only have two things to line it up with. So there's a little secret. You all know how to measure now. In order for something to be straight and parallel, it just needs to have two of the same distances, right? So take your stylus, capture a measurement down here from the edge of the paper to the ruler, bring it straight up. Is it the same? If not, make some adjustments. They should be exactly the same on both sides. And you'll have a nice, perfectly straight parallel line. I use that all the time. Here's another really good one. Again, you just have these two small points to work with. For everyone on the camera, it's just these two small points that we're trying to line up. So I'm going to check top and bottom to make sure I have a nice parallel line, because if our lines aren't parallel, that means our box is going to be lopsided. And a lopsided box will have two different dimensions, which will throw off our measurements. Okay. One more. And now we have a box. You can erase the excess if you want, but it doesn't really matter. There's just notations for our benefit. So next what we're going to do is we're going to divide into halves, quarters, and thirds. Halves, corners, and thirds. So I always begin by basically just making a guess, putting in a little dash here, little mark, and then I'm going to check it and see if that's right. Tip of the pencil, tip of the thumb. So look what I've got here. Tip of my thumb is at the bottom corner. Tip of my pencil is going to be where I've made a mark. Then I'm going to slide up, putting the tip of my thumb where that mark was, and we can see how far over the tip of the pencil goes. A good bit. So that means the original space is too large, because when I duplicated it, it shot me off past where I need to go, which means I need less space. I need to shorten it so I don't go so far. So we'll come back here to the original. Let's go a little shorter. Maybe let's try here. Tip of the pencil, tip of the thumb, come up. And we can see now we have a nice overlap with that point. So right here, this is going to be our halfway point. And the beauty of all of this is your two sides of the box are exactly the same. So once you've got one half over here, you can bring it right across. You can make a mark. And you can put down one half. Isn't that so convenient? Everything just looks like it's lining up so perfectly. Isn't that great? This is designed to hopefully not be too difficult to draw. You're going to find a lot of commonalities very easily. But very quickly, we will transition into drawing more and more complex things that will require more hunting. All right, so taking this kneaded eraser, getting rid of that extra mark that I don't need. Now, taking a half, divide it in half. Make a guess. Check your guess. Too short means it needs to go longer. Another mark, another guess. Tip of the pencil, tip of the thumb, bullseye. Get rid of your extra mark. One quarter. Now my 1/4 can be duplicated not just across, but can also be duplicated up. A quarter should go into a half 2 times. 1, 2. Lands on there exactly. So we're gonna make this mark here. This is gonna be 1/4. Translate this all to the other side. 1/4. Now, because these are the measurements that we are going to start off with, we are going to use these measurements a lot. Therefore, it is essential that you make sure these are as accurate as you can. Make sure you check them and double check them so that they are right. So next, let's try a third. A third is larger than a fourth, but less than a half. So let's make a mark for our guess. Tip of the pencil, tip of the thumb. 1, 2, 3. Way too much. Come down. 1, 2, 3. Too little. Come up. Let's try this point here. 1, 2, 3. Too much. Let's come down. 1, 2, 3. A little bit more. Now what you're going to find is the more times you have to move your pencil, in this case we're doing it 1 times, 2 times, 3 times, the more you have to move your pencil, the more little changes add up really quickly. And those little changes become very big changes. 2, 3. I'm losing my place here. I have a really hard time drawing and talking. You'll see me make silly mistakes because I have a hard time doing both. 2, too much. Down a little more. 1, 2. There we go. Make a good solid mark there. Good solid mark there. It's going to be my third. This is going to be my third. Get rid of those extra marks. Because if you take 1/4 of an inch and you're adding 1/4 of an inch, but then you are taking your pencil across the entirety of your sheet 4 times, your 1/4 of an inch is going to grow into an entire inch by the time you get to the end. This is also one of the reasons why we try to push for such extreme levels of accuracy in every step, because errors accumulate and build up over time. So if we allow one small error to get into our drawing, if we use that as a point of reference, every single time we use it, we are injecting that error into everything we do, which means then the things that we're building on, those can't be trusted, etc., etc. If you ever find yourself lost and things aren't working, always go back to your outer perimeter, your halves, quarters, and thirds, or half of your halves and half of your quarters and half of your thirds, or a third of your thirds, etc., because these are always going to be your most accurate points. So let's go ahead and take my 1/3 here, bring this over, 2, 3/3. 1/3 mark, that's a 1/3 mark. Now we do this for the bottom. 1, 2. 1, 2. Right here. It's going to be 1/2. Take that measurement, bring it up. Whenever I bring it up, I always check it as well. So I make my mark, so that's my half. Come over, make sure I put it in the right place. That is my 1/2. Next we can do quarters. Too much. is about right here. Always double check. Always be in the habit of wanting to double check. Double checking takes time, but it's a lot less time than fixing a messed up drawing. One, two, three, four. 1/4, 1/4. Now for thirds. 1, 2, 3. Nope. Let's try maybe here. 1, 2, 3. A little bit more. 1, 2, 3. So when I get to the end and I get that 3, I don't let go of my pencil. I go all the way back to the origin, and I use that to help me make my really solid 1/3 mark. 1/3. Again, come back in, clean up any stray marks that we don't need. No reason for them to linger and confuse us. Grab the 3rd, come up to the top. 3rd, 3rd, 3rd. Make sure you're being as accurate as you can. 1, 2, 3, 1, 2, 3, 1, 2, 3. So right here and right here. That's going to be our 3rd, and that's going to be our 3rd. So this one is done. Now we get to do the other. So it's a little bit of setup work, but you would do the same thing if you were working on, say, a still life, because these are all of the points that you need to do when you first start. In order to draw something, it first must be analyzed. You need to visually analyze what it is that you're looking at. We need to understand it at its most basic level in order to be able to draw it. That looks good. Here, this is going to be 1/2. Drawing takes a lot of time. It's the reason that art is so expensive. Your average book cover illustration, so say your favorite fantasy series, young adult fiction novel, that digital painting that is on the front usually costs upwards of $2,000 to $3,000 to commission. It's a lot of money. But when you break it down, it basically equates out to a 40-hour work week. Some paintings take longer. Some can take upwards to 60 to 80 hours. It just depends on the level of complexity. Okay. 1/4, 1/4. Thirds. 1, 2, 3. 1, 2, 3. We just keep marching our way up until we find it. 1, 2, 3. A little too far. The hardest part is just not losing your place. 1, 2, 3. Come back to the original. Make this one nice and dark. This is our 1/3. This is our 1/3. Double check. 1, 2, 3. 1, 2, 3. 1, 2, 3. Get rid of the extra marks. Translate those across. Make sure you place your marks in the right place. 1/3, 1/3. Okay, only one side left to go. Close. This is our half. Halfway point. Quarters. Last but not least, our thirds. Right on the money, right off the bat. 1/3, 1/3. Tip of the pencil, tip of the thumb. Make sure you don't go too fast. Don't make a mistake like I did. Take your time. All right, 1/3 and 1/3. So once we have this done, we've got everything we need to get started. So remember what I said last time. In order to go about finding any point in space, we just need 2 points. We need 2 points to be able to find it. Just like we were looking at a map, we need the longitude and the latitudinal coordinates to find a point. All we basically need to do here is make a connect the dots. We've got a bunch of corners here, we've got a bunch of curves. We just need a bunch of points on the corners and curves so we can then connect those dots. How many dots do we use? That's what you'll discover as you work. Sometimes you need more dots, like when you're dealing with a curve, or if you're dealing with a big straight line like this, you just need 2, because you know it's going to be a straight line. So, remember, to find any point in space, we just need to know where it sits on the vertical and the horizontal axis, which essentially means we need to know either how far up or how far down on the vertical, or how far over from the left or right. Once we know just one of those, all I need is one and the other, I can find any point in space. Simple? Excellent. So let's go ahead and let's try to just explore. And this is how this all begins. It's all just an exploration process. We have to just feel these things out and see how they end up working. So we can go from a known to an unknown, or an unknown to a known. What are the known measurements? The known measurements are anything that exists over here on this side, on our drawing. This is what we've deduced. We now have the knowledge of the height, the width, half of the height, a quarter of the height, the 3/4 of the height, 1/3 the height, 2/3 the height. All of those measurements are things that we'll be able to use. So, for example, let's just look off right here. Remember, we need 2 coordinates, right? How far over, how far down, or up. If we plot anything that is on the outer perimeter, that means that it's touching one of the outer boundaries, half of the equation is done. Because we already know how far over, it's all the way. It's all the way over, or it's all the way at the top, or all the way at the bottom. So when we plot these, that makes it a lot simpler because we only have to find one of the 2 dimensions. So that's where I like to start. One of the easiest ones to do is just take a look right here. Look at the halfway point. We're already right at a corner. So we can come right over here. We know how far over and how far down, and we can put a little circle. I like to do little dots. A lot of times I'll also put a little dot over here. Your silver graphite will show up on the black, and I'll put a little dot. And once I have kind of confirmed for myself that I know a location, I put a nice solid dot there, so I know that I don't have to keep plotting for that. That part is done. So let's look at an unknown. Let's try to figure out an unknown measurement, and we'll take it into some of our knowns. I have no idea if this will work, by the way. I know that drawing will work, but I don't know if the measurement that we are going to take is going to fit all nice and neat into the data that we have at the moment. we may need to bounce around between a couple different things to find something that goes in nice and easy. We kind of tackle all the easy stuff first. We then have more measurements and more things to work with. So then when we tackle the harder things that don't seem like they fit in right now, they'll probably then fit in later because we'll simply have more options to take them into. So remember, we compare this to this, then we stop, and then we can compare this to this. So what I'm going to do is I'm going to find the width of this box, or I should say the width of this line right here. So I'm going to go from this point to this point here. I'm going to capture that measurement. Follow along. These will be free measurements if we figured them out. So I'm going to capture that measurement. Tip of the pencil, tip of the thumb, right along that edge. So I've got that right here. So what I need to do is now take this unknown distance. It's unknown because I have no idea what this fits into. And I need to compare it to some known or established measurement. That is everything that exists over here. Now remember, we're not crossing. We're just consulting. So let me consult with what I've already figured out. Those are my halves, quarters, and thirds. So let me go to the halves, quarters, and thirds that I have over here, and let's take a look. Let's see if it goes in, how many times it might go into a quarter, if at all. 1, 2, 3. Take a look at where this stops. You see where that stops? Look at where the quarter line intersects with my pencil. If we were to call that a fraction, what would we call that? Probably call it a half. 1 times, 2 times, 2.5. So we know the width of this box goes into a quarter of the height 2.5 times. It's a little weird and complicated to say, but if you talk to yourself while you draw, even if it's just in your head, it will help. Talking in your head has been proven to help a person stay on track, to stay in place. That's why when you're reading, when you read, you're saying the words in your brain, and it's what helps keep you on point. So if you talk to yourself as you draw, it'll actually help keep you on track. But we don't have to stop there. We don't have to stop at just going 2.5 into a quarter. Maybe there's something that goes in even easier. Let's keep exploring. Let's see what else we might have. Well, we know that from here to a quarter would be the same as a half. So let's see if we went all the way into a half, how many times that would be. 1 times, 2 times, 3 times, 4 times, 5 times. That makes sense, right? If it goes into a quarter 2.5 times, and then we multiply that by 2 to get 1/2, we would end up with 5 times, right? Makes perfect sense. Well, whenever we're measuring, we always want to try to get as a whole number as humanly possible because it's much more accurate. It's a lot less guesswork going on. So going into 5 works out pretty well. But there's also something else we want to think about. Whenever we do these little measurements, every time we move our pencil, there's always the risk that we're going to mess up, that we're going to go a little too far or not far enough, and we'll introduce an error. So as much as we can, not only do we want to try to get a whole number, we want to try to move our pencil as few times as possible. So you want to hunt around and try to find what this can go into as little as humanly possible. Sometimes 5 is the best we're going to get, or 2 1/3 will be the best we can get, and we'll just have to go with it. But know that as a general rule of thumb, always hunt for whole numbers and always hunt for as few times as humanly possible. That's always going to get you the most accurate result. So it goes in there 5 times. Let's check our thirds and see how our thirds feel. So we did the 1, 2, 3. It's going to put us short of a third. Let's try the 2/3. 1, 2, 3, 4, 5, 6. We're still short here on the third. If we go over, it's like 6 2/3. Well, a solid 5 is far more accurate than 6 2/3. It's less times in the movement, and it doesn't have a fraction. But all of these halves, quarters, and thirds, those are all relational to our height. Our width is totally different. So if we put it into the width, we're going to come out with very different results. So maybe if we try the width, we'll find something that works even better. Let's try the width. 1, 2, it's over a quarter. 3, 4, 5, 6, 7. So it goes into the total width 7 times, but 5 is still less than 7. So the one that we're going to want to use is the distance from this point to this point, goes from here to here 5 times. So you've done a little exploration. We found the one that it fits into the absolute best. So 5 times. Okay, so let's come over here. I've completely released the measurement. I am not carrying that measurement over at all. What we're gonna do is now work backwards. So over here, we started by going from this unknown distance, and we compared it to something we've already solved. Well, when we move over here, that unknown distance isn't here. But what we do have is the halfway point. So now we're gonna go from a known and we're gonna deduce out. We're going to figure out what is 1/5 of this half and use that to figure out what the unknown measurement is. Does that make sense? Unknown, what we're solving for, into something we already have divided to create something we don't have. Forwards and backwards. So let's go ahead and try to figure out what is 1/5 of our total height on our drawing. We're just gonna make a guess here. 1, 2, 3, 4, 5, too much. A little bit smaller. 1, 2, 3, 4, 5, too short. You'll notice when I move my pencil, I like to dip down to make my mark. So 1, 2, 3, 4, 5, just about there. 1, 2, 3, 4, 5. So basically about right here. That is our 1/5 of the half. 1/5 of the half. Now, when you get down to these tiny little measurements, what you end up having is as errors get introduced, it is because of mechanics. It's because of your eye-hand coordination, trying to figure out how to move this, big old fat pencil for these little itty-bitty marks. That's just a natural part of the drawing process. You'll get better and better at that as you go. So now that we have this, and it goes in 1 times, 2 times, 3 times, 4 times, it goes in there 5 times, we're gonna take this distance now. 1, 2, 3, 4, 5. We're gonna go back to the origin point. I'm gonna raise my mark up here just a hair, just a little bit. Just a little 1/5. 1/5 of my half. What we're gonna do now is we need to take this distance right here and we need to place it correctly in the drawing. Now, this is easy to do because when we're plotting this point right here, we already have half of the information. We know how high it is. It's 1/2 of the height. We're just trying to figure out how far over. So what I'm gonna do is take this dimension right here, capture this, bring that up, turn it to the horizontal, bring it to the halfway point, come right over, make a little dot, and I encourage you to draw an actual dot. When you turn this in, if it looks like I connect the dots, that makes me happy. It makes me happy because that means you're thinking through the actual points, okay? So that's totally fine. And just like that, you now have your first line of your drawing. And it's kind of an important one too, isn't it? Because take a look at how many things are similar to this dimension. This dimension is probably the same as this dimension. It's probably the same as this dimension, probably the same as this dimension, so on and so forth. Which means we can now use this as a point of reference when we do the rest of the drawing. We now know more. We have more known measurements. We now have this distance that we can work with. So for example, let's say we wanted to figure out what is the distance from our top left corner over. Well, we know how far up and down because it's on the most extreme point. We just need to figure out how far over this is. So let's check this unknown measurement and let's put this into a known. That's not just our halves, quarters, and thirds anymore. It now includes this because it exists over here. Who would have ever guessed these are exactly the same? Release. Come over to the drawing. Pick up that measurement. Go back to where it was. Make a mark. You can always double check. Now we have another point. So we've got this point. I wonder how we're going to get this point over here. Now in this case, with this point, we know how far over it is because it's somewhat obvious, and we know how far down it is because it's somewhat obvious. So we can go ahead, take any of these known measurements. We don't have to go through all that extra work. And double check all this. How far down? It's going to be this line. How far over? It's going to be the same line. Right here. Draw a nice line. Draw a nice line. You can always go back with a ruler later if you want to get yourself a nice crisp line, but that will serve our purposes here. So we've got a nice, consistent square going all the way down. See, it's not too hard. But let's jump to something a little bit harder, a little bit trickier. It's one thing when half of the measurement is done for you, when half of the work is already done. When half of the work is already done because you're using the halves, quarters, and thirds, and you're drawing something that's already coming out from the edge, that's somewhat simpler because half of the work is done. But let's just jump towards the center and let's find something more difficult. So let's say, I don't know, could be any one of these. Let's do this point right here. I'm gonna put a little arrow here so we can kind of stay on track. We're gonna do that point right there. In order to find this point, it is not on the edge anymore, which means we need to be able to figure out how far over from one of the sides it is and how far either down or up it is from the top or bottom. We need two things to find a coordinate, which means we have 1 distance, 2 distance, 3 distance, 4 distances that we could pick from when trying to figure this out, okay? It's typically always easier to work with the smaller distances. Smaller things go into bigger things. So it's usually the safer one to go with. So let's take a look. I'm gonna go from the farthest left. I'm gonna grab this point, pick up that point, and let's compare it to our knowns. What do those include? Halves, quarters, and thirds, as well as this dimension here. Could go into any of those. Now, since this is a really big one, we can't take that into this little guy. Not the way that we're doing it at the moment. It's too big. So let's take it into some of our bigger measurements here. Oh, well, that's convenient. It goes into 1/4 exactly 1 time. Release. Come over here. Pick up your 1/4. Got it? Oh, but wait a second. Where do I put it? I know how far over, but I don't know how far up and down. At this point, what you need to do is just make a guess. Just go ahead and put a point down. But what I do is instead of making a circle, I make a little X. It just helps me keep things straight. That this tells me I have figured out how far over something is, but I still need to figure it on the vertical axis. Only little circles are things that are done. X's are things I'm still trying to figure out. Sometimes, if I was just starting learning this, you might even put a little arrow here, something you can erase later. Okay, so that X, I figured out how far over this is. Next, let's do the vertical. Okay, so let's grab the vertical. The vertical. Compare this to my known measurements. What do those known measurements include? Halves, quarters, and thirds. The distance here, 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 and here. But also the distance from here. That is now one of my knowns. Not only that, I also know the other side as well. I have both of those distances. So let's compare it. Nope, too big there, too small here. Let's take a look. So I remember that point. 1, 2, 3. Notice where it stops right there? 3 times. Do we have that point plotted? We do. It's right over here. So 3 is pretty solid. We could probably just stop at 3, but just in case, 1, 2, 2.5. 3 is better than 2.5. So let's do 3. So all we need to do is divide the distance between these 2 points into 3 parts. Divide those into 3 parts. Just make a guess here. 1, 2, 3. Ooh, super close. Let's make a little mark here so we have our point of reference. Grab that real carefully. 1, 2. A little short. So that means we want more space. 1, 2, 3. Right there. So 1, 2, 3. It's this little guy right here. You can take your eraser, get rid of all of those extra little marks that you don't need as they start accumulating. So that distance right there, that is that 1/3. 1/3 from the bottom left up to this point. That is how far how far down. That is what we computed, right? It's going down from the top. So how far down this exists. So I'm just going to line up with the X, check to see where the tip of my pencil is, make sure it's still up in line, and then we can make a circle. So, again, going from the top down, getting that dimension. So 1, 2, 3 to that point, finding the same 2 points over here, dividing that into 1/3, 1, 2, 3, then using that to push the X down however far it needs to be right. At that point, I have plotted both. I can get rid of my X, and I have found another coordinate point. That is all the drawing process is. That's the whole thing. And you just keep going, and you keep going, and you keep going. Now, you take a look at where this is. You should be able to eyeball, if you look between here and you look between here, that probably looks like the same as here, right? Which means this is probably half of that. So, take half. Does it go in twice? 1, 2, it does. Come over here. 1, 2, it does. So I could come over here, take half, come over here, put down a half, come over here, could put down a half, and then I can start plotting even more things. Could come down again that same amount of height and just keep working. And that's how you draw. That's the whole thing. It's just doing this over and over and over and over and over again. Over and over and over, okay? Now, with that said, what most people do is they start up here because it seems like a nice, easy place to start, and then they slowly, systematically move their way down here, okay? Here's the problem with that. You're gonna have little errors that are gonna build up. And as you keep using those measurements and you start using the new ones that you're building, by the time you get down here, you may have built up an error that's like a 1/4 inch or more, okay? So a good practice, you've heard of best practices, right? When you're on the job, best practices. Best practice when you're drawing is to work the entire scene all at once. Do a little bit over here, then do a little bit over here, then do a little bit over here. And when in doubt, always compare to your halves, quarters, and thirds. Those are always going to be the most accurate because they're always the simplest to find, okay? So, with that said, you're probably wondering a little bit about these curves. How in the world do I do a curve? Corners make sense because it's a point, but how do I plot a curve? You could plot any point in space, any. You could literally just make an artificial dot and plot the dot, as long as you can find that it fits into something nice and neat. It goes into either a whole number or a nice simple fraction, 2.5, 2 1/3, etc. But there are ways that we can make these curves a little bit simpler. One, plot the apex of a curve. Apex of curve. Do you know what an apex is? It's this point right here. It is where the curve is the most extended. It is where it is pushing out the absolute most. So we can put a point right there. Now, it probably is a bit logical. You can probably tell by looking at these shapes that if you were to divide this shape perfectly in half, you're going to find that apex. So try to find that point there. If you have this point here and you've plotted this point here, you can then freehand that curve. Now you may say, whoa, I know that you want this to be as accurate as a photocopier. I don't want to freehand nothing. This is what you do. Add more points. The longer the distance between 2 points, the harder it is to draw an accurate straight line. The smaller the distance, the easier it is, right? So come back, do another point. Plot that point. Figure out where that one goes. Then, just like connecting the dots, if you have this point, this point, this point, this point, and this point, it should be very simple to go 1. That is the worst curved line I have ever drawn. Don't do that. Be very methodical. Try to get a nice, really nice, gentle curve. There you go. And you're just connecting the dots. That's all there is to it. Now, for the presentation of this document, all I want are lines and dots just like you see here. Okay, just lines and dots. Okay, and you're going to draw out this whole thing. You can leave all of your little halves, quarters, and thirds. You can leave all your little annotated marks. That's all perfectly fine. With this is a working document, okay? So it is okay if it's got eraser marks and all of those other things, okay? We're not as concerned about draftsmanship. Just please don't wrinkle or crinkle or mess this up. Treat it like you would any kind of, written MLA paper that you might turn into a teacher. Just keep it nice, stick it in a folder. When we get to the drawings, like what we have up there of the boat and the fruit and these other things, draftsmanship will be something that we are going to care a lot about, making something look very, very professional. But that's also why we have tracing paper, because the drawing process is very messy. It's a very messy process. So you go and you plot and you figure and you deduce all the answers to all the problems, and then you simply transfer all of the correct things to a final beautiful piece of cardstock. And that's how you get drawings that look like that, these drawings that you look at and you marvel. It's like, how could anyone just do that? Well, that's because all of the mess, all of the working out, all of the things that had to be figured out, they're all done on other pieces of paper that you don't see, okay? So, that's the whole drawing process. Point, 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 connect all the dots. Now be aware, you're gonna find a lot of things go into things 1/2, 1/4, 1/3. There are some tricky areas in some of these zones. Don't make any assumptions. I have specifically put in some of these little guys that are really weird, wacky widths. So you're gonna have to compare them against a lot of different things, or have to use thirds and halves, 2.5 or 2 1/3 in order to plot some of these things, okay? So as you work, you're gonna find the system. The system will kind of reveal itself. But I put a couple things in there to trip you up. Always, always measure. Follow the system I have here for you. If you do that, you will succeed. Because after we do this, we're gonna be drawing a picture of an old man made out of squiggly pin lines upside down. There will be no system. There will be nothing obvious, and you will have to hunt and find to figure out what squiggle goes into what other squiggles the best, okay? Use the system. One other last note. What is this? What is this, class? It is a straight edge. It is not a ruler. There are no numbers on here. The numbers are irrelevant, okay? They are irrelevant. Don't be going in here and trying. If I see a math problem on your paper because you've used calculus somehow to try to figure out some kind of curvature or some kind of percentage, I will be very cross. A, because you're making your life so much more miserable, and B, you're not following instructions. I know learning new things is painful, and it's a lot easier to use things that you already know, but I promise, once you can do this, you'll be able to draw so much better, so much more accurately, and finally when you draw in your sketchbook, you won't run off the side of the page anymore. It'll be great, because you'll finally be able to work within a box. So, that is the drawing process. Keep that in mind. Ask your instructor if you have any questions. And again, we are going to repeat this after we finish this one. So you will get a second chance. You're going to get a second chance at this. So just do your absolute best with your understanding as it sits right now, and it's just going to get better. Cool? Excellent. Good luck.